Dun, 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 dun. Welcome back to another Pre-Narculus production featuring a brand new theme song to help people get more excited about math and Narculus. Narculus, like and subscribe. Today, we are going to talk about partial fraction decomposition, another exciting event. Today, we are up to type 3. The good news is we are up to type 3. Type 3 talks about quadratic, non-repeating factors. Okay, so the good news is we are up to type 3 of partial fraction decomp. The bad news is there are 5 types, and we are only up to type 3. So the first thing we need to do to talk about type 3 PFD is to go back to a definition that we used back in the first video, which is the definition of a proper fraction. A proper fraction was a fraction whose degree in the denominator, the degree of the factor, let's say, the degree of the factor in the denominator was larger than the degree of the factor in the numerator. All right, and this definition actually guided us through the first 2 types, okay, and it will continue to guide us through type 3. So let me talk to you about how it actually guided us through. Let me remind you. So in type 1, we had fractions that look like this, okay, or something like this. And we wanted to decomp them. So we pulled them apart. We wrote 1 with an x minus 1 and 1 with an x plus 2. And then we put an a and a b on the top, right? That's how we did it. But we decided that there was an a and b on top because of the factor that was in the denominator. This factor is a linear factor. It's degree 1, which means that if you have a degree 1 factor in the denominator, you can't put anything bigger than degree 0 in the numerator. So degree 0 would just be a number. So we called that number a. And then over here was the same thing. We had an x plus 2. X plus 2 is degree 1, right? It's a linear factor, okay? So on top, we had to put something degree 0. So we put a b, just a number, all right? So that was type 1, okay? And then we moved on to type 2. And we actually followed the same definition, whether you recognize it or not. So in type 2, it got a little bit more interesting. It looked like this, for example. So we said, okay, there's an x squared, an x minus 1, an x minus 1 squared, and an x minus 1 cubed. Okay, those were all our denominators. So now, remember, everything is based off the factor that's in the denominator. Here, the factor is x. It's a linear factor, so we put a letter a on top. The next term also has a factor that's an x. That factor happens to be squared, okay? But the factor is x itself, all right? It came from here. It's just that we squared it when we got to the next one because of the x squared. So the factor is degree 1. So on top, we put a b. The next term was an x minus 1. This was degree 1. So on top, we put c, just a number. The next term has a linear factor. Here's the factor. The factor is x minus 1. It happens to be squared. So it was degree 1, the factor was. So on top, we put a d. And then here, the x minus 1 cubed, again, the factor is x minus 1. It's degree 1. So on top, we just put an e. All right? So all of these factors that we had were linear. Now, some of them were raised to higher powers, okay? But they were linear factors that were being raised to that power. That was type 2. So now let's talk about what type 3 looks like. So type 3 looks like this. So x squared plus 4 times x squared plus 3. Now, here are your two factors, your x squared plus 4 and your x squared plus 3. Neither of them can be factored, right? It would have to be x squared minus 4 for you to factor it. It's not. And if it were x squared minus 4, you would have to factor it. Okay, but this is not, so we can't factor it. So it's going to be my factor. And then my other fraction is going to have x squared plus 3 as its factor. Okay, now look at your x squared plus 4. X squared plus 4 is a quadratic factor. It's x squared plus 4. It's degree 2. That's the thing that's inside the parentheses, degree 2. So that means on top, you could actually put something that's degree 1, because the only rule for it to be proper is the degree of the denominator has to be bigger than the degree in the numerator. Okay, so technically degree 1 is allowed, but degree 1 would look like something that's linear. So on top in the numerator, we are going to write ax plus b. Okay, this is a linear factor. A linear factor could have a number times x, but it could also have a number by itself, right? That's also technically valid. Okay, 4x plus 5, that's linear. 3x plus 2, that's linear. 4x minus 7 is linear. Okay, that's all degree 1. All right, so this factor up top actually accounts for my both degree 1 and degree 0 term, because if a happens to be 0, it won't be there, and then you'll be left with b, which is degree 0. Okay, so it does account for both. And I actually put it in parentheses because of what we're going to do later on. All right, so now over here, you also have a degree 2 factor, x squared plus 3. So on top of it, we are going to put something that's degree 1, which is cx plus d. All right, so that's how you're going to break down type 3. All right, so now you're going to put linear factors in the numerator if you have a quadratic factor in the denominator. All right, so let's try one that's a little bit more, we're just going to try to put this in the right form. Okay, we're not going to actually decomp it. It's quite long here. So let's try x squared minus x minus 1 squared, and we'll try x squared plus 2 times x squared plus 2. Okay, so now we're going to have an x squared, and x minus 1, and x minus 1 squared, and x squared plus 2. Okay, those are my 5 fractions. Now, here is a linear factor, x. On top, you put a number, a. Here is a linear factor that's being squared. It's a linear factor. So on top, you put b. Here is another linear factor, x minus 1, 3, 1, c. Here is another linear factor. I don't care that it's being squared at the end. I just care that this factor is linear. On top goes d. And here is a quadratic factor. This is degree 2. X squared plus 2 is all grouped together. On top, you put something linear, ex plus f. All right, that's how you would set up your fractions to be ready to go. Okay. All right, that's the idea. That's how we're going to set them up if they're quadratic. Okay, so let's see if we can do some decomps. All right, let's try to decomp. Let us start with this. 8x cubed plus 4x squared minus 2x plus 6 over x to the 4th plus 6x squared plus 8. So now, this denominator factors, right? It actually factors. It's a quadratic type. But instead of x and x, if it were x squared in the front, it's x squared and x squared. And then find the numbers that multiply to be 8 and add up to 6. So that's 4 and 2. Okay, so I'm going to leave the numerator off for now. It would come over here. It's just a little bit lengthy. So now we have x squared plus 4 is a factor. Neither of these factor again, right? Because of both addition. And x squared plus 2 is my other factor. So on top of the x squared plus 4, you are going to write ax plus b. Okay, because this is degree 2. So on top, you can put degree 1. Same thing with this factor. This factor is degree 2. So on top, you can put degree 1, cx plus d. And I'm going to put them both in parentheses. You'll see why in a minute. All right. So now, so far, we've set up the right form. So now the next step is the same step as it was before. You're going to take the numerator from over here. Let me come over here. I'm going to need some room. So we got ax cubed plus 4x squared minus 2x plus 6 equals. And I'm going to find a common denominator. So I'm going to have ax plus b. The first term is going to need the x squared plus 2. The second term is going to need an x squared plus 4. Okay, and we're all set. All right, now, for the first two types, you learned what was called the Hevesy method. So named after a guy whose last name was Hevesy, which basically involved you picking strategic values for x, okay, to knock out the variables so that there'd only be one variable left. All right, it's a great method, but not in this case, because the problem's going to be, what number do you plug in, for example, to like x squared plus 4 to get both c and d to cancel? You need this to be 0, the x squared plus 4, when you put your number in for x. But there's not going to be a number that you can put in for x to make this a 0. So you're not going to be able to cancel these two c and d out. Nor are you going to be able to cancel the a and b out. So now you got a big issue, right? You're stuck with all this, okay? If you put 0 in, you could get c and a to cancel out, but you'd still be stuck with b and d. So that's not helpful either. All right, it's not going to get you just one variable, okay, to solve for. So what we're going to do is we're going to use a process called equating coefficients. Okay, equating coefficients. So here's how it works. The first thing you're going to do is we're just going to rewrite what's on the left. We're not going to touch what's on the left at all for now. On the right, you're going to FOIL this. Okay, that's how you equate coefficients. All right, we're going to FOIL it. So if we FOIL it, we get ax cubed plus 2ax plus bx squared plus 2b plus, I'm going to have to get rid of the coefficients here. So this is cx cubed plus 4cx plus dx squared plus 4d. All right. So I FOILed that. It was a mess. Didn't take too long. I FOILed. Okay, next step is you are going to group together the like terms on the right-hand side. So now, here's the thing you got to understand. You can't combine anything on the right-hand side. None of these are like, because they all have different letters in them, right? Like, so for example, the ax cubed and the cx cubed both have an x cubed, but a and c, I don't know what they are, so I can't put them together. I just have to write ax cubed plus cx cubed kind of next to one another. Okay? And I'm going to cross them out as I go, just to make sure I remember to put all the numbers. Or I put everything that was here. Next, I'm going to go to the x squared. So I'm going to put them in standard form. I got bx squared and dx squared. All right, so I'm going to put those two next to one another. And then I'm going to have 2ax and 4cx go next to one another. Okay, and then finally, I'm going to put the two guys that don't have a variable at all, 2b and 4d, next to one another. All right? All right, now there's a reason I did this. It's because what I want to do is I want to factor the GCF from these two. These two have a GCF, it's x cubed. Okay, so I'm going to take out x cubed, but I'm going to put the x cubed in an unorthodox place. Normally, I take the x cubed out and I put it in the front. Instead, I'm going to put it in the back. So I'm going to take out x cubed, write it in the back, and I'd have a plus c. Now, what I have here is valid. You could distribute this way, okay? But normally we don't. In this case, it actually makes sense to do it. And I'll show you why in a minute. So in the next two terms, I'm going to take out x squared, but I'm going to put the x squared, oops, this should be a d. I'm going to put the x squared behind the b plus d. All right. Next two terms have an x in common, so I have a 2a plus 4c, and take the x out, put it at the back. And then finally, I just have 2b plus 4d, which I'm going to group together, but they don't have a common denominator, and that's okay, and you'll see why in a minute. Oh, this is a d. Sorry, guys. Can't see it. 4d. Okay? All right, now here's the trick. What we're going to do is we are going to equate the coefficients. Here's how it works. It's pretty simple. Okay? Once you reach this point, it's simple. All right. What we want is we want the left side to be exactly the same as the right side. We need them to be equal to each other. Okay? So we actually know some stuff about these variables that are over here on the right. For example, let's start with x cubed. On the left side, there's an 8 in front of the x cubed. On the right side, there's an a plus c. So what I know is I know the following. I actually know, and I'm going to erase this so that I have a place to write these. I actually know right now that a plus c will have to equal 8. Because if it doesn't, these two sides can't possibly be equal. These are the only two numbers that are going to have x cubed in it. So I need a plus c to equal 8. Next, in front of the x squared on the left is a 4. I need there to be a 4 on the left for x squared. On the right, it says b plus d. So I need b plus d to equal 4. That's a 4. Okay. Next, I have a negative 2x. See it? There it is. It's negative. Okay. On the right, I have a 2a plus 4c in front of an x. So I know that 2a plus 4c has to equal negative 2. And finally, I have some numbers by themselves. On the left, it's a positive 6. On the right, it's a 2b plus 4d. So I know 2b plus 4d has to equal 6. Okay? This is called equating the coefficients. Coefficients are just the numbers in front of the variables, right? So I'm literally taking the numbers in front of the variables and making them equal to each other. The one side happens to be a number. The other side happens to be letters that are being added together. Okay? Now I have 4 equations with 4 unknowns, so I should be able to solve this. And if you look, so you can start to understand, I bet, at this point, why we made you do that lesson on systems before we started partial fractions, and this is the big reason why. Okay, if you take, for example, these two equations together, you should be able to solve it by elimination or substitution, whatever you want to do. So a plus c equals 8, 2a plus 4c equals negative 2. And then I would choose probably to multiply the top equation by negative 2. That would give me negative 2a minus 2c equals negative 16, and 2a plus 4c equals negative 2. So I have 2c equals negative 18. So c is negative 9. So now if c is negative 9, I can put c in here. I'll have a minus 9 equals 8. So a is 17. So there's a, 17, c, negative 9. Okay, let's go on. Now take these two equations, work those two together, and you should be able to get b and d. All right. So we have b plus d equals 4, and then we have 2b plus 4d equals 6. If you multiply the top equation by -2, you'll get -2b minus 2d equals -8, and 2b plus 4d is equal to 6. So these drop out. You get 2d equals -2, so d is -1. That up there. And then if I put d is -1 in this equation, I'll have b minus 1 equals 4, so b equals 5. And there's your 4 letters. Okay, your 4 variables solved for. So finally, we can write our final answer, which involves you taking these numbers and putting it into our fraction over here, which is why I didn't erase it. And your final answer will be 17x plus 5 over x squared plus 4 plus -9x minus 1 over x squared plus 2. Which you could also write, since the second term, both of these are negative, you could technically take the negative out, and you could write, if you wanted to, just so you know, if you see it like in the back of the book as an answer, could write negative in front and then take the negative out. You took the negative out of both. And if you ever distributed the negative back, you'd get back to where we started again. So you can write this as well. Both of these are valid. Both of these will get you full credit. Okay, that's how you do it. All right, and that process that we used is called equating coefficients. So let me summarize equating coefficients for you before we go on to the next example. So equating coefficients. Okay, so basically what you do is you FOIL the right side, put the terms in standard form, and then factor out common GCF. So what I mean by that is, for example, if you have an ax cubed and a bx cubed, then you take out the x cubed and write a plus bx cubed. If you have a 2ax minus 4dx, you take out the x and write 2a minus 4d times x. But if you were to have just an ax cubed and a bx squared, you would not factor out a GCF here because these terms are not common. Okay? They're not like terms. All right? Only the like terms do you factor out the common GCF. Okay, these aren't like, so I wouldn't factor anything with this. I just leave this the way it is, like this, and then your final step is equate coefficients with the left side. All right, and we're going to practice this in a minute again, just so you get the hang. Okay? All right, so there's what you would do. Okay, now let's try another one. All right, let's try. We're going to try partial fraction decomp for 3x squared plus 4x plus 4 over x cubed plus 4x. All right, so the first thing you're going to do is you're going to factor, right? Factor on the bottom, you can take an x out. You get x squared plus 4. The top, I could bring it over. I'm just not going to do that. Just save some marker. So the first term would have, first fraction would have an x in it. Second fraction would have an x squared plus 4 in it, right? I can't factor this, right? It's not the difference of two squares, it's the sum. All right, so now let's talk about what we need. This fraction factor in the denominator is linear. So it just needs a number on top, like the last two types. The x squared plus 4 is degree 2, it's quadratic. So it needs a bx plus c on top, because it could be linear on top. All right, so we have to consider that. Okay, so the next step would be to multiply, or I'm sorry, find a common denominator here again. So the first term is going to need the x squared plus 4. The second term is just going to need the x. All right, just going to need an x. Okay, so now what I'm going to do here is I'm going to first equate the coefficients. All right, I'm going to do this by equating coefficients. Then I'm going to show you another way that you can use, which is kind of like a hybrid, which works really well sometimes. And I'll show you a few examples, or an example of that in a moment. So let's just equate the coefficients here so that you get the idea. First thing you do is FOIL. Okay, multiply it out. All right, so we'll have 3x squared plus 4x plus 4 equals ax squared plus 4a plus bx squared plus cx. All right, so this is one where it works out really nice. Okay, now we're going to put these in order. Okay, put them in standard form. We have ax squared. We have bx, they come first. Then the cx. Okay, ax squared, bx squared. Then the cx. And the 4a doesn't have an x, so it comes last. We are going to factor out any like terms, GCF. So ax squared and bx squared are like terms. So we're going to factor out the x squared, and we're going to write it at the back. Then we're going to leave the cx, and we're going to leave the 4a by itself. All right. Now we're going to equate the coefficients. Here we go. We'll do it over here in the corner. All right. So what do we have? On the left, we want there to be a 3x squared. We want there to be a 3 in front of the x squared. On the right, we have an a plus b in front of the x squared. So we know a plus b has to equal 3. For the next term, on the left, we have a 4 in front of the x by itself. On the right, we have a c. Only a c is in front of an x. That's it, nothing else. So then we know c equals 4. We already know it. It's already done. And finally, we have a positive 4 on the left by itself, no variable. On the right, we have a 4a with no variable. So we know 4a equals 4, which means a equals 1. And if a equals 1, put 1 in up here, and you get b equals 2. And there are your 3 variables. All done. Pretty quick, right? Pretty quick. All right, so now we can write our final answer. So our final answer would be, let me erase this, because I don't want to erase this. I want to show you another hybrid. Oh, I just erased the answers. So I got a is 1, right? So I have 1 over x plus, or 1 over x plus b is 2, right? So we have 2x plus c is 4 over x squared plus 4. And there's my answer. That's my final answer. It's decomposed. Okay? Now, I'm going to go back here for a second because I want to show you a hybrid method that works really well sometimes. All right? Depending on the scenario that you're in. And I got the answer. I erased it. I showed you got the same thing, but it's okay. All right. So there's a hybrid method. The hybrid method is like a combo of the Heaviside method that you use for types 1 and 2, and this method called equating coefficients. So basically what you would do is you would look at the right-hand side and you would say, hey, all right, is there anything I could put in for x right now that would eliminate and allow me to get answers? And the answer to that question is sure, right? If I plug in 0 for x, it would eliminate b and c, right? Because this 0 would have to be distributed to both of them. It's going to give you a 0. And the only thing left would be a. So if I let x be 0, I get 0, 0, 4 on the left. On the right, I get 0 plus 4 is 4a. And then b and c both drop out. So a is 1. I already know a is 1. Okay? Now, is there anything else that would help me in this path? No, right? So there's no other way for me to eliminate 2 variables. Okay? I can't do it other than 0, right? Anything I plug in for x here is not going to eliminate a. Nothing's going to eliminate a at all. All right? I can't eliminate a, and the only thing that will eliminate b or c is 0. 0 would eliminate b, and 0 would eliminate c, but I already used it. Okay, so I did get A. So now, if I go and equate the coefficients, what I could do is I could replace A with 1. So here's what happens. I get 3x squared plus 4x plus 4. And then I distribute the 1. So I get 1x squared or x squared plus 4 plus bx squared plus cx. So now I'd have 3x squared plus 4x plus 4. And I do the same thing I did. I gather my terms together, 1x squared plus bx squared. And then I'd have a cx and a 4, right? And now I could factor out my x squared and put it in the back for my like term. So I have 1 plus b, x squared plus cx plus 4. And then I have 3x squared plus 4x plus 4. And now I can equate the coefficients. I know 3 is equal to 1 plus b. I know c is equal to 4. And I know that, well, the last equation is just 4 equals 4, which just means that you found a correctly, okay, when you did it with the other method. So this doesn't do anything for you. But this gets you c, and subtract 1 on both sides, and you get b. And those are the same 3 numbers we just had a moment ago. All right? It's another way to do it, okay, to use this hybrid method. I'll show you an example real quick here of a place where that hybrid method kind of comes in real handy. So let's try another partial fraction decomp. One more, and then we're all set here. So on the bottom, you can factor. You can take out a GCF. It's x. And now this will factor, right? X cubed minus 1. This is the difference of 2 cubes, okay? That formula that you keep forgetting, right? That everybody forgets all the time. So this will factor as x minus 1. The a is really 1. The b is also 1, right? Because this is x that's being cubed. Oops. This is x that's being cubed, and then 1 that's being cubed. Okay, so that makes a x. Sorry, a is x, and b is 1. So I'll get x from here. Then x cubed minus 1 will factor as x minus 1, x squared plus x plus 1. All right. Now, the good news is when you factor a cubic, if you remember the formula correctly, after you're done, see this quadratic here, x squared plus x plus 1, it will never factor. It'll never factor again, as long as you factor correctly the first time. Okay? If you're factoring the cubic. All right? So now let's write our fractions. So our fractions are going to be, we're going to have 3, it looks like. It looks like we're going to have an x and x minus 1 and an x squared plus x plus 1. So on top of the x, it's a linear factor, goes a number, a. Here's another linear factor, b. Here's a quadratic factor, cx plus d. Okay, now I have to refine the common denominator. All right, so let me refine the common denominator, and we'll set it equal to x squared minus 4. Then we may translate everything up to the top because I'm going to run out of room down here. All right, so the first term, the a, will need an x minus 1, and it'll also need an x squared plus x plus 1. Then the b will need an x and an x squared plus x plus 1. And then the cx plus d will need, that in parentheses, we'll need an x and an x minus 1. Okay, all right. So now let me get rid of this up here. I'm also going to put up here, let me put all the way up here, this guy. So we have a over x, because I can't forget which order I wrote it in, b over x minus 1, and then cx plus d, x squared plus x plus 1 for when we're all done and we write the final answer. All right, that way I can get rid of this. And we're going to translate all this up. So we have x squared minus 4. Let's see if I can copy it right. Ax minus 1, x squared plus x plus 1, plus bx, x squared plus x plus 1, and then plus cx plus d, x minus 1. Okay, that's it. All right, that's everything. All right, so I can get rid of this. Okay, now here is a great place where the hybrid method makes a lot of sense. The first thing you would have to do if you weren't going to equate the coefficients would be you'd have to multiply the entire thing out. That's a lot. But if you make strategic choices, you can knock out some of these variables and get some of the answers right away. For example, if I put 1 in, 1 will knock A out, right? Because you'll get 0 here, and then 0 times this will be 0, and then I don't care what this is because the number is going to be 0. B will stay. C and D will get knocked out because this will be 0 here, and then you'll have to take this 0 and distribute it to both of the C and the D, so it'll make both C and D 0. So let X be 1. You get -3 on the left. On the right, A drops out. You get B times 1. 1 squared is 1, plus 1 plus 1 is 3. And then C and D both drop out. So you get -3 equals 3B. So B equals -1. So let me stick that up here. I know B equals -1. All right, now let me pick again. So I can also pick 0. 0 is a good choice because 0 will drop B out. 0 will drop here. If I put it here, it'll drop C and D out. Okay? 0 will drop C and D out. So now when I put 0 in, I get -4 on the left. On the right, I get A times -1. 0 plus 0, 0 plus 1 is 1. B drops out from here. C and D drop out from this 0. When I put 0 here and I distribute it, C and D both go away. So I get -4 equals -A, so A equals 4. All right, there's 2 answers right away. Okay, now I'd like to get C and D. The problem is anything that I pick now for C or for D would not drop, or for X, would not drop C or D out. Okay? C and D are going to stay in no matter what. So now you actually have 2 choices. You could continue picking variables for X, picking numbers for X. And just as long as it's not 0 or 1, you'll get something with a C and D in it. Okay? You'll have to pick twice, right? Pick twice because C and D will be 2 variables. You'll need 2 equations. So you'll have to pick 2 different numbers for X to get something for C and D, like you did in the last type. Or the other thing you can do is you can replace the A with the 4 and the B with the -1, and you can now FOIL this. It's up to you. I am going to FOIL it because I just want to show you what happens. All right, so you get x squared minus 4 equals, if I FOIL this, let's see, how can I do this? Let's FOIL this first. It gives me 4x minus 4, and then I'm going to FOIL it with this. So that's 4x cubed plus 4x squared plus 4x minus 4x squared minus 4x minus 4, which should be something very familiar momentarily. And then I'm going to FOIL this in. So I get -x cubed, -x squared, -x. And then here, what I'll do is I'll take these two, distribute this. It gives me x squared minus x if I multiply these together. And then I'm going to FOIL this with this. So I get plus, let's see how much room I have, cx cubed minus cx squared. Cx squared plus dx squared minus, can I fit it? dx. I don't think I can, so we'll put it underneath here. We'll say minus dx. Okay? All right, so I FOILed the whole thing. Now, a lot of these things over here are going to cancel out. This 4x squared, this 4x squared, this 4x, this 4x. And what you get is you happen to get 4x cubed minus 4. If you take the 4 out, you get x cubed minus 1, which is what happened when we FOILed, or when we factored the x minus 1 times x squared plus x plus 1, right? That's what we got when we factored x cubed minus 1. That's why it comes out that way. All right, now let's equate the coefficients. So we have x squared minus 4 equals We have 4x cubed. We have minus x cubed. Cross those out. We have plus cx cubed. Cross that out. And we have plus dx cubed. Oh, no. Oh, no, that's right. No, is it? It is not right. Nope. It's a dx squared. This is a dx squared, not a dx cubed. That does not belong there. Okay. All right. That's it for the x cubes, I think. Okay, now let's go to the x squareds. We have a negative x squared, and we also have a negative cx squared. Okay. Right, that and that. Okay. And then we have also a dx squared plus dx squared. All right, let's put that there as well. Okay. And then we have minus x and a minus dx. And we have a minus 4. All right. So now let's factor out. So if we take out x cubed, we'd have 4 minus 1 plus c x cubed. And then if we factor out x squared, we're going to put a plus here. We're going to leave this as minus 1 minus c plus d x squared. And then we'll put a plus here again, and then we'll have minus 1 minus d, take out x, and then minus 4 by itself. Okay, now we're going to equate the coefficients. So this is what I want to show you. This is why I equated the coefficients instead of just pick numbers. So here I have 4 minus 1 plus c x cubed, right? On the left, there are no x cubes, right? There are no x cubes over here. So I know that 4 minus 1 plus c must be equal to 0. There are no x cubes, and this is what's in front of x cubed on the right. So I need the right-hand side to give me a 0 here so that it matches the left-hand side. There are none. Over here, there's a 1 in front of that x squared. So I have negative 1 minus c plus d equals 1. Okay. Over here, there are no x terms. So I have 0 equals negative 1 minus d. And then the negative 4's match, which just means that I got a right about a half hour ago. Okay? All right, so now we can just finish this real quick, right? It's pretty easy. You don't even need this equation in the middle. You don't even need it because you get d equals negative 1 here, and then this is 3 plus c equals 0. So c equals negative 3. So there's my other two numbers. So we have c equals negative 3. Oops, can't see it. C equals negative 3. And we're going to have d equals negative 1. All right. So now we're all set. We can write our final answer after about 15 minutes to a half an hour. So we are going to write our final answer, which will be 4 over x minus 1 over x minus 1 plus c is negative 3x, d is negative 1 over x squared plus x plus 1. And then if you'd like, since they're both negative, you could take the negative out and put it in the front and write 3x plus 1 up on the top, x squared plus x plus 1. And this is the correct answer. You're all done. Okay? All right, so that was a little bit about a lot of stuff. All right. Number one, how do you write the factors here, okay, if they're quadratic? Okay. And then how to use the equating coefficients, how to do that, and also how to use the hybrid method where you kind of combine the two methods where you pick things for x, but you also multiply it out to try to make it your life a little bit easier. All right? All right. Thanks for clicking. Enjoy doing those problems.